Wow. Okay, good, Carl. If you could just introduce yourself and then take it away.
Okay, I'm gonna try and share my screen at the same time here. If I put that full screen, everyone sees that fine? Okay. Well, thank you very much. My name is Carl Mitchell. I am a professor in the Department of Physical and Environmental Sciences at the University of Toronto, and specifically on the Scarborough campus. And I've been in and around McKellar since I met my wife about, it's 27 years ago, and have owned property McKellar for maybe 15 or 16 years, I think now. And so I've been around a little bit, and not on Manitouwabing itself, but I'm going to talk a little bit about how this whole project kind of came together, I think, in my first slide here. So thanks for coming out. Today, I am going to talk about, we did a study last summer on Lake Manitouwabing to investigate largely phosphorus cycling and to think about the nutrient status in the lake and different aspects of the lake that would possibly have an impact on some decisions that could be made, or just inform some things about what's going on essentially with the health of the lake. So just a brief history about how this study came about. I think probably all of us.
Hello, there's a Starbucks near the entrance to the subway. Am I going in the right way? Thanks.
Well, I think everybody probably hopefully in agreement that water and water quality are paramount to the economy and recreational enjoyment of McKellar. And there have been some small issues that, as I understand, somewhat sporadic in the relatively recent past. And there has been some research that's been done, taken some data that exists, specifically some stuff by Bev Clark, who did a State of the Basin review. And as a function of that review, there were some recommendations in that review for some things that could be further examined. And so I also happen to be a volunteer member of the townships, or the lake and the villages, I guess, Lake and Stewardship Environment Committee. And I happen to be a professor, and I teach hydrology and watershed management, and kind of live a research life about water. And so I volunteered to engage some students from the university in doing some research and trying to essentially take a crack at some of the recommendations that Bev Clark made in his report, both using some existing data and some modeling and some collection of new data and new measurements to try and understand a little bit more than we already know. And so essentially, there's, the harder you think, the more you can kind of come up with different environmental issues that could exist, but it's important to kind of think of these issues in context, and try to get some context about what are minor issues, what are major issues, what are things that should be prioritized, what are things that are less important currently but could be important later on, these types of things. And so a lot of this study is trying to kind of think about at least part of the things going on in the lake, and try and think about how we could get some evidence for some decisions about the committee, for example, and what kind of things to work on for education or more examination, for example. So just briefly, phosphorus, I'm going to mostly talk about phosphorus cycling today. And phosphorus is, important. It naturally occurs. It also is mined and used in things like fertilizers. And so there's multiple kind of ways that phosphorus can get into the environment, but the primary ways are in runoff from sources that are kind of rich in phosphorus. Those tend to be things like agriculture, wastewater, certain natural covers, especially wetlands. There's phosphorus in several products, And the runoff generated in different situations can get into lakes. The organisms that live in lakes need phosphorus to grow, especially plants. It's the same reason why we would add fertilizers to agricultural fields. Also helps algae and other photosynthetic organisms in particular, but other organisms to thrive in these systems. And essentially, under many circumstances, phosphorus kind of gets taken up by these organisms. They eventually die and kind of fall to the bottom of the lake and tend to accumulate, or the lake pushes the phosphorus that's in the lake out of its outflow to downstream areas and accumulate there. And we can monitor the health of a lake according to a number of different things, but two very popular things and relatively approachable things are measuring the concentration of phosphorus, that's this total P number that's here, and things like Secchi depth. And Secchi depth is this little instrument here, and you drop that in a lake, and it helps you to understand the clarity of the water. And so if you had a lake that had significant algae buildup and significant growth of organisms in the lake, it would start to impede your ability to see through the lake, and you would lose vision of a Secchi disc like this in a short amount of time. Whereas if you had a very clear lake without a lot of productivity, you could drop that Secchi disc for a number of meters before you would lose your ability to be able to see it. And so we classify the lake trophic status, or kind of like the nutrient status of lakes, according to phosphorus, Secchi depths, and there can be other things like chlorophyll A and things that help to kind of assess where we are. So essentially you can have something like an oligotrophic lake, which is a very clear lake, something you might get in some of the areas around, say, Killarney or Algonquin, sometimes deep lakes with lake trout, and very clear, lower productivity lakes. On the very other end, you have eutrophic lakes. They tend to be green, very, very productive. And then in between, you have mesotrophic lakes. And this is actually where Manitouwabing sits, is in the between area as a mesotrophic lake, which is in many aspects has good pieces of both ends of these kind of lake trophic status. But a worry, and so lakes kind of move from an oligotrophic status towards a eutrophic status naturally over relatively long time periods. But when people get involved and things start to be added to the landscape, or people disturb the landscape in a number of different ways, the amount of phosphorus that gets into the lake can change. And phosphorus, more than any other nutrient in almost all freshwater systems, tends to be the nutrient that most limits how much plant growth and algal growth and productivity overall that can happen in a lake. And so that's the reason why we tend to be really interested in phosphorus, because it is really the linchpin for what makes things move from one place to another in terms of its trophic state and its productivity. And the danger is that too much phosphorus can lead to an overproduction of algae, and you can get these blooms, and they're unsightly, and sometimes they can stink a little bit. Other than that, they're not too bad. You can get harmful algal blooms, which produce cyanotoxins, although most algal blooms are not harmful algal blooms, and they require some specific testing to figure out if the algal blooms are harmful and produce toxins. So that's a somewhat separate but related issue. But the more immediate issue is sometimes when you have this overproductivity of algae, eventually it will die and it will fall to the bottom of the lakes, and microbes and other organisms will start to eat it up because it's like fresh dinner. And as they eat it up, they consume a lot of oxygen. And as they consume oxygen, it removes it from the water column, and it affects badly. It can affect organisms, including fish and their habitat. And so, the bigger worry of a highly eutrophied system is that you could have things like fish kills, for example, because of too little oxygen in the water, or at least maybe localized things that can happen that are caused by that type of thing. So moving into Manitouwabing, it's a pretty complicated lake. Actually, I'm sure you all know it's a relatively big lake, but it's also very oddly shaped, like almost like a big spider. In this picture here, it's hopefully not to confuse everyone. It's the blue that is the lake. So the lake's kind of small in this picture, and these large areas are actually the watersheds that feed streams that actually enter into the lake. And I don't have the streams on here exactly, but some areas of the lake have relatively large areas of land that contribute runoff into the lake, and some areas are quite a bit smaller that contribute runoff into the lake. But back prior to the 1870s, what we know as Lake Manitouwabing was actually 3 separate lakes connected through little streams and wetlands, and then a dam was built and flooded, and so now we have this multi-bayed lake that has kind of a plethora of different habitats, ranging from in the middle of the lake, right in around here, that's about 110 feet deep, to areas that are just a few feet deep, depending on where you are in the lake. And so when I was trying to think about how to kind of advance some of the things we know about the lake, we decided to try and take advantage of the fact that the lake was kind of self-sectioned off into different areas in these different bays, and had kind of different regions to the lake, and then therefore take advantage of trying to look at this over space and do some modeling and some measurements to try and think about the things that most influenced how much phosphorus was in different areas of the lake. So overall, we used existing data. So there's been this lake, the MLCA and the township have been involved with the Lake Partners program for, I think, about 18 years or so, collecting data, which was paramount and extremely useful to being able to look at some things and do some modeling in this lake. And so we used a readily available model. I'm not going to say it's the most predictive thing in the world, but it helps to kind of think about what things are influencing what's going on, and what we might not know is oftentimes how I use modeling. I'm kind of happy when I have not success trying to model something, because when I don't have success trying to model something, it means that there's something going on that's not in the model that we don't necessarily understand. And that helps to kind of think about the things that we should therefore look at differently and try to understand, so that we understand the system overall a little bit better. And so we started with this modeling framework in different areas of the lake, and then did some additional measurements, some additional water sampling, and went out and took some sediment cores and made some other velocity measurements and things like this to try and think about some hypotheses. And then specifically with the lake sediment, look at different forms, different chemical forms, and how the phosphorus is actually sitting in the lake sediment, and whether or not there's something to worry about in the lake sediment in terms of having a large pool of phosphorus sitting in the bottom of the lake that would, if there were attempts later on, if there was ever eutrophication, major eutrophication of the lake, that would slow down the ability for the lake to kind of clean itself, or interventions to help clean the lake. If you have large amounts of phosphorus in the sediment, you can have some issues that could maybe make that process much longer. So we used a model from the Ministry of Environment, Conservation and Parks called the Lakeshore Capacity Model. It has inputs that include runoff and flow estimates from different areas in the watershed. You use land cover, especially things like the amount of cleared land and wet proportions of wetlands, and then lot type, especially shoreline lot type. So are they residential and seasonal lots? Are they permanent resident lots? Are they campgrounds? Different things like this. And it essentially assigns the expectation of different amounts of phosphorus that come in from these various potential sources into the lake. And using this model, we broke it into these different sections of the lake. And I would say, so this section up here, give you an idea, like Minerva Park is up here. And this is Tate's Island. And if you go down here, the Herdville Dam and the exit of the lake is down here. Jennifer, I think your cottage is in around here. And I think Susan cottage, anyways, the people on the committee, I can pick out their cottages from different places in the lake and kind of pick these sections out and try to essentially use the model and what we call mass balance, try and think about the inputs and outputs of phosphorus that are coming into different areas of the lake, and then see if we can successfully mimic mathematically what's going on in these different sections to match it up with measurements that we actually take in the lake to estimate how much phosphorus is in there. And then take these samples back to the lab in Toronto and measure them for total phosphorus and something called soluble reactive phosphorus, which is the main dissolved form. And the students collected, and I helped them out a little bit, but they did a lot of the collection to give Chelsea and Julie a lot of credit in May and June and July and August at 10 different sites. They did a bunch of other measurements, including oxygen and temperature profiling and sediment collection in different areas of the lake. And so this is most of the sites. I did notice this a map from Chelsea, one of my former students, and there's at least one site missing on here that I can highlight. So we have another site right in the middle of the lake, right in and around here, the kind of very deep part of the lake. But essentially you have, sampling here, for example, to kind of quantify how much is coming in from Lake McKellar and entering the lake here. And then the narrows right here to try and therefore quantify this as a section. There's another sample here, which is collecting what's coming off of this arm that's kind of in this area here. The golf course is just right in this area. There was some interest just to see if phosphorus concentrations happen to be higher near the golf course. This is a Manitouwabing River inlet, so we were trying to there's a large watershed and parts of the lake that deliver water in through here. And then once you enter into the Herdville arm, for example, there's the arm, the water as it moves down here, and then at the dam, collecting water essentially as it moves over the dam. And then we did a little bit of sampling right here that didn't actually start until summer, just a little sectioned area of the bay, just off of the northwest side, I guess, of Tate's Island. Oops. And then tried to do some sectioning here, I will say, at what we call South Tate. And then some of these areas were orange triangles. We did some deeper sampling in addition to sampling right at the surface. And where we had black dots, these are largely just samples from the surface because the overall depth in these areas is quite shallow. I don't want to blow you away with too much data. I'll try and I bring this up just in case people are curious, but this is the background data to try and understand how the lake, kind of the physical properties and some of the chemical properties of the lake change over time. And so these are different places in the lake. So near the golf course and, just in from the main part of the lake towards the Herdville Dam, and where the Manitouwabing River kind of empties out in the main part of the lake, that South Tate part I was talking about. And then in the very middle of the lake and in the middle of McKellar Bay, all this stuff on the left is dissolved oxygen, and it goes from the surface down to wherever it happens to be in terms of how deep that area is. So some of these are, 5 meters deep or less, and some of them, like the middle of the lake, are about 30 meters deep. So there are kind of different depths that are here. But what you can see is the lake does stratify, of course, and that's not to not be expected. And so what that is you have, water is most dense at 4 degrees Celsius. And so as it kind of warms up at the surface, the cold water is kind of trapped in the bottom. And so you get quite different parts of the lake. So for example, in the middle here, you get this upper part, and then you get this lower part. And this has to do really with the temperature of the lake, and then the use of oxygen by organisms and other things that are in those different parts of the lake. And so these upper parts tend to have higher oxygen concentrations, and the lower parts tend to have lower dissolved oxygen concentrations. And you can see, for example, that in the middle of the lake, even though it's quite deep, the dissolved oxygen concentrations don't get that low. Whereas in different areas like the Herdville Arm there and McKellar Bay and parts of even the Manitouwabing River Inlet, the concentrations of dissolved oxygen near the bottom, right above the sediment. So this would be generally less than a meter above the sediment where we'd stop. We try not to kind of jam instruments into the sediment before we get there. And so some of these do drop. And then where they do drop, it's the same places on the right here. Where they drop to close to 0 or to 0, you can use another, it's another instrument on the kind of multi-instrument that we use that's called oxidation reduction potential, or we shorten it up as ORP. And ORP gives you an idea of kind of the types of processes happening once that dissolved oxygen might actually drop below 0. And so the more negative they get, or even it doesn't even have to actually be negative, the more kind of anaerobic processes that can happen, more deeply anaerobic processes. So things like methane production and organisms start to eat up and almost breathe nitrogen instead of oxygen, and they start to breathe manganese and iron practically instead of oxygen, those types of processes. So, somewhere even like the middle of the lake doesn't really drop, and so the oxidation reduction potential stays quite high, whereas, even the golf course late in August, to be expected, starts to drop a little. So you can expect kind of different processes to happen. And the reason this is important, I'm going to get to it in a minute, is that these types of processes impact whether or not the phosphorus stays stuck to the sediment, or whether or not the microbes that live in the sediment and the bottom waters actually force chemical reactions that eat up the bonds that are holding phosphorus in place, and then allow phosphorus to kind of move back into the water column and become available for organisms to eat up and flourish and be productive in that sense. So that's the reason that we look at these things. These are all the different places that we sampled. And, sorry for the abbreviations, but these are things like the Herdville Arm for deep samples and surface samples, and the Herdville Dam. I think this is the Manitouwabing Narrows, or McKellar Narrows, right near your place, Susan, and the McKellar, the Manitouwabing River Inlet and South Tate, and near the golf course, and then near that other place, that little spot that we had, a little small embayment up on the west side of the Tate's Island Causeway, or the bridge there, as an example. Overall, and this is, something that's just in the overall records, the concentrations that exist in Lake Manitouwabing put it fairly squarely as a mesotrophic lake, on average about 18.5 micrograms per liter. We measured a little bit higher in 2021 than is kind of like the historical average. Does that mean anything? Not really. That's one of the reasons that it's really good that data is taken over many years. There's different things that can affect things from year to year, but still a number that suggests that the lake is not in dire straits. there is some variability in that number in these different sections of the lake. I'm just going to change something real quick here. And like is normal, those concentrations do decline over time during the summer, and this has to do because plants use it and algae uses it. But importantly, at some of these deep sites, say in the Herdville Arm, and even the golf course in here, you actually, even in the deeper spots over time, we're tending to see concentrations over time that are declining or staying relatively stable. And this is a good thing. It tells us over the summer, as these kind of lower oxygen conditions develop in the lakes and some of the places that are deeper, the phosphorus is mostly probably staying in the sediment where it is, and it's not necessarily being particularly actively cycled into the overlying water. Another complicated graph, and I'll try and walk everybody through this. It honestly doesn't matter that much if you look at the left and the right. We're kind of using our own data from 2021, and this is kind of average historic data that exists for the lake. These are the different sections of the lake again, and this is us running the model and then comparing our model outputs to the concentrations that we actually get during our sampling, so what we call the real concentrations. So I'm going to encourage you to ignore these red bars, but really the green bars are what we measured in our samples, and the blue bars is what is predicted in the model. And so we tend to, in a lot of places, get a little bit more phosphorus than the model is telling us. It was a little bit worse in the year, but there is some variability from year to year, like I mentioned, in 2021 versus kind of the mean historic. The middle of the lake was actually pretty bang on in terms of the modeling telling us what was going on, but different areas of the lake were kind of the Herdville Arm down the lower part, not so great. South Tate, not bad. Manitouwabing River Inlet, not bad. McKellar Bay, kind of in between. This upper arm that empties out near Camp Manitou, not too bad. Modeling is a bit of a nuanced science, but this tells us essentially that not bad, but there are probably other things that are going on that are not necessarily captured in that particular model. And so what we then did was look at different things that exist in the lake and or different things that we're feeding into the lake from the watersheds that are feeding water into these different sections of the lake, and try to see in a relatively simple sense if there are areas that the deviation of the model kind of was being influenced by these different things. So the main things that we looked at were the internal loading of phosphorus from the sediment. So if phosphorus that could come in, was there, where we were under predicting, were there issues with the loading from the sediment? Natural inputs from wetland areas or potentially inputs from agricultural areas. The golf course was of interest to people. Septic tank maintenance issues. I'm going to talk about that for a minute, but I'll tell you that there's only so much kind of evidence you can get, and then shoreline vegetation loss. And so as an example, this is what the chemistry is of the sediment in different areas of the bottom of the lake. So this is McKellar Bay, just a little bit out from the dock. Maybe there's a deeper spot where you often see fishermen out from Minerva Park in the middle of that embayment there. South Tate kind of area, which is quite deep. And then the main Lake Manitouwabing kind of bays in the really deep part that's in the middle-ish area of the lake. And essentially most of what we see is bound in this kind of middle area, which we call this oxide bound phosphorus. And this is like a form of phosphorus that tends to be stuck to oxides of iron and aluminum and is moderately stable, but if you get really low oxygen conditions in the sediment, can be moved back out into the lake. There are not everything else. The other forms that we had were really quite low concentrations compared to this, but it's just kind of the upper 20 centimeters or so, but you can see it's also kind of relatively stable, at least in this main form, as you go down in the sediment. So it tells us a couple things, that there hasn't been like these any enormous inputs of phosphorus somewhere in the relatively recent history that will be grabbed by those top 20 centimeters of sediment, and that you have this moderately stable form that could be disturbed, but these concentrations, it's hard to contextualize these concentrations sometimes, but they're not really all that high. They're nothing that's outrageously high. They're kind of boringly normal, frankly. And so that's a good thing. And there's more work could be done here. And you know, it becomes a bit academic. You could look at sediment iron geochemistry and aluminum geochemistry, and we could look at the actual fluxes. You can take some cores and do some experiments to see, you know, situations where the phosphorus is moving into the overlying water. But just remind you that we could go back and look at that time series in the deeper parts of the lake, and the phosphorus was actually going down in concentration or staying relatively stable, which suggests that the fluxes are actually not very important out of these areas. So, you know, sometimes some of these things probably aren't necessary, and come to a conclusion that things are relatively okay here. And that essentially that the internal cycling or movement of a lot of phosphorus out of the sediment currently, at least in 2021, into the lake was not something that would be driving huge differences in phosphorus concentrations. One of the things that Bev Clark brought up was about wetland runoff into the lake. And we have, you know, a somewhat correlated amount of phosphorus in different areas of the lake, according to how much wetland area is kind of feeding into those different areas of the lake, but it's not particularly strong. There's a couple of outlier points like this. And, you know, there is an influence here, but not a strong influence that would suggest it's kind of like the major thing that's pushing what's going on. And this is agricultural land cover in different areas of the lake. And that as well is not real. It's not, you know, a flat line like this suggests that there's not a strong influence from agricultural inputs. Now it is correlation. You know, correlation is not always causation, but often when you have poor correlation, it tells you that it's tougher to actually put a cause on that, and it gives you some indication that that's likely not that important. And a big question was, you know, what about old or poorly maintained septic systems? Are they an issue? I'll say right up front, I don't think we have enough data to exactly say one way or another, but we're pointed towards this particular area to the kind of northwest of Tate's Island that anecdotally, but records are hard to come by. There were some thoughts that probably this was an area that might have some older septic systems. It was an area, I don't know much about the area, to be honest, was developed a little bit earlier on. But when you look at this area in particular, so if anybody knows a bit more about this, I'm happy to hear about it. But when you look at this area, it's not anything particularly different from everywhere else. In fact, the numbers, if anything, are about the same or even lower than other areas of the lake. And so it does not necessarily support at this time that septic systems are a major issue, but there's a lot of things that we don't know. And this is a pretty, you know, relatively rudimentary, small amount of data investigation as to what's going on. Another question was about the golf course. Do golf courses add phosphorus? People have seen that, golf courses can add phosphorus potentially in runoff into different areas of the lake. But if you do things that's try to potentially suck up that phosphorus, maybe they don't have a big deal. That maybe doesn't make a big deal out of how much goes in. So we did see a little spike in concentrations in July, but it's a weird spike. It's tough to attribute exactly what that is. It could be weather, it could be a number of different things on a particular day, but generally we have, other than this spike, these downward trends and concentrations. Even this number is not that huge, and the concentrations are not that far off lake averages. I mean, when I go, we've puttered around in the boat a little bit, quite a bit on the shore to have a look. When you look at some maps and kind of look around, there is relatively good vegetation conservation in the shoreline in this area. There's not a lot of runoff that's generated from the golf course into the lake. And so most evidence here points to the fact that what's going on at the ridge, at least in terms of phosphorus concentrations and runoff, there's not strong evidence to suggest that it's making a huge impact on phosphorus in the lake. One thing that does come up in the data, at least fits a hypothesis, is about shoreline vegetation loss. And so my master's student Chelsea last year took a bunch of ortho photography and looked quite manually. Actually, I was talking to her the other day because I didn't quite understand entirely how she did this, but literally looked at a bunch of photography and did some measurements using GIS to try and figure out where there is apparent vegetation loss. And so things where there's a lot of grass that goes right down to the lake, or beaches that are right on the lake, what I would call unnatural type of cover, versus things where there's trees and shrubs that are in quite serious abundance at the lake shore. That would be an area that does not have significant shoreline loss. And there is a fairly good matchup, other than the overall lake itself, which is frankly tough to match up with this type of hypothesis. So I'm putting it aside a little bit. But the areas where we had trouble modeling a little bit, where things were off more, there is more shoreline vegetation loss in those areas of the lake. And so that fits with the hypothesis. And we do know that shoreline vegetation is important for sucking up phosphorus and taking it out of the water column and filtering a number of different contaminants. And so it does make some sense that this is potentially an issue, especially in maybe McKellar Bay area, which I call McKellar Bay, and in that area up towards Minerva Park, and then the Herdville Arm that goes down towards the Herdville Dam. Those kind of areas seem to be something that, are areas to take a close look. So this is not my final conclusion, but kind of scientific conclusions. The Lake Manitouwabing is in fairly good shape. Phosphorus concentrations are higher in some places, but there's not significant or persistent algal blooms that happen here. And the concentrations of phosphorus that we are seeing are, put it squarely, as a mesotrophic lake. Right, good for fishing, but not overly nutrient rich, and a lot of kind of green outbreaks everywhere that you might expect in a eutrophied lake. Shoreline vegetation loss and potentially some natural landscape factors that Bev Clark already kind of pointed to, like wetland cover, are, in my opinion, at least from the data that we have in hand, the most likely cause for differences in the phosphorus concentrations that we see in different parts of the lake. Something like wetland cover is not something that you're going to really manage for. And I love wetlands and studied wetlands for a long time and believe in their conservation. So, I mean, shoreline vegetation loss is the main manageable thing at play here for Lake Manitouwabing. And sediment accumulation of phosphorus is not huge. appears stable currently. And so the lake seems to be, working well in terms of how phosphorus is naturally cycled within it. And we don't see any kind of evidence for any kind of huge phosphorus inputs in the past that have been accumulated in the sediment. So I kind of promised to kind of focus a little bit on some implications for taking this data, and what do you think? What are some things to think about? One, it's like I pointed out earlier, it's not that clear from the available data, and there's not really that much available data, that poorly maintained septic systems are adversely affecting the water quality as it relates to phosphorus. Now, it makes intuitive sense that poorly maintained septic systems could be an issue, but the evidence is not clear that they are. And so more work would needed to be done to try and make an evidence-based link. And some things to start, it would be good to talk to the local installers, and especially people that are maybe redoing septic systems, and think about what the soils and the areas that are being excavated actually look like. You can see evidence kind of color-wise in soils and things like that of major runoff that would occur in the subsurface if that exists. That anecdotal information might be one of the better ways to think about whether or not there are potential issues that need to be pursued. Education and potentially rules. I prefer education first. About natural shorelines is something that the data is probably most strongly suggesting could help. And it's also something that's relatively manageable. So that if you have more vegetation coverage at the shore and even up into your property potentially, it's going to suck up more phosphorus. It's going to store it eventually in the organic sediment. It's going to be held there. They also reduce the amount of runoff that moves from land to water, because more plants use more water, and so less water is left to actually produce runoff and move things off of the landscape and into the lake. They also suck up what's in the runoff, and they reduce erosion, both erosion coming from waves and things like that from the lake, and from erosion from the landscape, which might actually move phosphorus. So phosphorus loves to be attached to particles and stuff as well. And so if you can stop particles from moving one way or the other, you can also keep the phosphorus kind of locked in somewhere where it's not having a huge impact. So I will say it's difficult to say. People often ask me, okay, well, how much vegetation should you put in? What should you do? I would say the first step is to do anything. And, if the more, the better. And it's very difficult to say, oh, you should do 10 meters, or you should do 2 meters, or you should do 30 meters. It really is different. It depends on the slope of your landscape. It depends on how close the rocks are to the surface. It depends on many other things. There are things, I've looked at the McKellar official plan a few times. There are things that hit on vegetation cover at the shoreline, and trees in particular. It seems to be ignored to me in practice, but it's not, I'm not kind of constantly on the lake looking at what's going on. But there are mechanisms here to think about potentially down the line. And then finally, kind of, what would I do going forward? What's my opinion? So I think, the tools and the willingness to do what's needed, in my opinion, already really seem to be in place. If people are interested in kind of having evidence and using that evidence and making some decisions. And so, number one, this Lake Partners program and the townships and the MLCA's participation in the Lake Partners program has been going on for quite a long time. As a scientist, there's nothing more useful than long-term information. I totally encourage that to hopefully continue for a long, long time. A year here and a year there is very difficult to interpret, because things like weather and different construction things that are happening in a particular year, all of these things can affect readings. And so this longer history of sampling is really invaluable. And, from what I've seen, is not all that expensive. I would continue the annual deep water dissolved oxygen measurements in late August and early September. This is when the lake is kind of most stratified. and just a few sites will be good. There's not a lot of really, really deep places in the lake, but this is a bit of a canary in the coal mine type of measurement. It's super cheap, relatively easy to do, takes a little instrument, and can tell you, help you to infer if there's an issue without trying to do a lot of expensive things. Consider tracking phosphorus concentration in the deeper waters in just a couple of sites around the lake over the kind of summer 3 or 4 month kind of May through August type period. Not necessarily even, I say long-term monitor be great, but this is a little bit more difficult to do. Even if it was every few years, it would help to see whether or not different processes are happening. It would be, again, something that would actually tell you the lake is changing its behavior. And then continue education, continue supporting people that are trying to help out and teach people about things like natural shorelines, and eventually potentially consider other actions if education doesn't seem to work. But those are the things that are, in my opinion, relatively easy to do, and even though they are easy, very worthwhile and very helpful for keeping an eye on making sure that the lake is a sustainable place for use going forward. So final thoughts. I've been involved in the committee for a few years now, I guess. I'm starting to lose track of time over COVID. But the township's really quite lucky, have all these different committees and volunteers that are from different areas that are quite engaged with environmental issues and monitoring. There's a lot of value for money in these things, and I hope to see those things continue for a long time. But it's important from a philosophical standpoint to try and think about things that can avoid issues when it comes to the environment, especially larger scale environmental issues. When you're thinking about not just your backyard, but entire lake and all your neighbors and all these different things. It's easier to avoid issues and much less expensive, to avoid issues than it is to see issues emerge and then kind of be forced to deal with them. The latter, kind of dealing with issues after the fact, is extremely expensive. Whereas trying to avoid issues in the first place takes some persistent effort without a lot of reward, but is a really much more straightforward way of trying to intercept something that's about to happen or could be happening. And a lot of the things that happen in the lake, it comes down to education. It's difficult to actively participate. Some people are really keen on environmental issues, and some people are not. And it is what it is. And it's difficult, though, to actively participate, I think, for some people in an environmental initiative, for example, when it's not all that clear that what somebody might do is actually going to help. Where's the evidence that's going to help? But I think those kind of things, if you think about how things work and more people understand kind of how the lake works, then that helps. And when you have more people understanding, more people being able to kind of think about things, then it also helps to see when things come up that other, many hands make light work, and can help kind of think about, something might be in need of relatively immediate action, or something that we can handle over a long period of time. It's just there's been a bit of a change. And then when something does happen, then that's kind of where something like regulation might come in. But I kind of advocate for education first. Okay, well, thank you very much. I'm happy to answer any questions, but that is the end of my talk.
Okay, thank you very much, Carl. I've changed this back to gallery view, so if anyone has any questions, we'd certainly be happy to entertain them. You can either put up your digital hand, or you can raise your hand to ask a question. I have one question. Occasionally we come across people clearing the shoreline and their lot near the shoreline and putting in an artificial beach. And I just wondered if you could comment on the effect of that on the health of the lake.
Yeah, sure. Oh, maybe a bit of feedback there. Yeah, so any, plants naturally take up phosphorus, and so a beach does not support plants for the most part. And I get it, people want beach, but the fact of the matter is removing the plants reduces the lake's capacity to self-regulate its phosphorus. And so I advocate against it, but I think, and I'm not as familiar with all the local rules related to conservation authorities and the township itself in terms of the development right at the shoreline, but I think it's something that needs to be potentially examined.
Okay, and another question I have is if you could just state what can the average cottage owner do to continuously promote the health of the lake? I know you've talked about quite a number of things around this, but just in summary, what if we have our cottage, what can we do as part of our normal practice at the lake to have as healthy a lake as possible?
Sure. So number one, Jennifer, you might have to mute yourself and have feedback. Okay, perfect. Number one, revegetate or leave your shorelines alone. Number two, keep an eye on your septic system. If you see wet areas downstream in your leaching field, if you have constant issues with your septic system, make sure it's pumped every couple of years. Those, there are some relatively easy things to maintain your septic system through time. At some point, leaching fields can fail and they need replacing, and those are decades long, but that happens. And so those things need to be examined. And honestly, I think there's zero need to fertilize lawns in backyards that face lakes. It is a direct potential input of phosphorus into the lake, because phosphorus is in practically every fertilizer in relatively large quantities because it's needed for growth, but it tends to be over applied. And when it rains, it runs right off into the lake and can be a major contributor. So, I would avoid having a grass lawn that goes right down to the lake, and I would avoid fertilizing that lawn and trying to live along the lake as close to as naturally as it might have been before you were ever there.
That's great. Does anybody else have any questions that they would like to ask?
Hey, Carl.
Go ahead.
Steve McDonnell here. I wonder if you could comment on geese eating grass on nicely cultivated lawns and the effect on the phosphorus getting into the lake.
Yeah. So geese are attracted to lawns, and so it's another thing to consider. Their poop definitely has phosphorus in it, and so having a large number of geese pooping on your lawn because the geese are attracted to lawn, so it's kind of this vicious circle that can go, does not help. Geese naturally live in and around the lakes, though, so I think like there is a certain, it is a less, the geese themselves are less of an unnatural impact on the lake than having a lawn that attracts geese to a certain spot. And the lawns themselves, because the kind of this open vegetated environment that doesn't have, you know, much roughness at the surface, these little short grass things, it doesn't stop much water and poop and whatever else from actually running off into the lake, you know, so they get the double whammy. So it's really the lawn more than the geese, in my opinion. But yeah, I don't have a very good feeling for, you know, if I were to mass balance how much phosphorus comes out of geese poop in the lake, I think it would be relatively minor compared to many other things, but that's off the top of my head. But I think the problem would be exacerbated, I think, as you're kind of maybe intimating there, that having the grass attracts them in the first place, and then you kind of get into this somewhat vicious cycle that way.
Does anyone else have a question?
Yeah, Fern Harris, I have a question about wild rice.
Yeah, go for
Go
it. I hope I can
I have
answer.
a question about wild rice down around the Herdville end. It seems to be taking off over the last 10 years. It's completely filling in some of the back bays. Do you have a concern about it? What it will do to the lake?
No concern from a quality standpoint. I mean, maybe an aesthetic standpoint. My guess would be that the rice was quite substantial at one point in the lake, if it's kind of starting to come up. I can't think of an environmental quality issue that the rice would be having an impact, and I don't know exactly what the species are, but generally in shallow lakes in Ontario and all across the kind of region from here to several thousand kilometers away, wild rice is relatively native to the area. So yeah, I think probably boating through it in different areas is not that easy, but I don't know enough about rice ecology to kind of say, but I can't think of a water quality issue that would come from rice.
Then I have another question too. Many years ago, there was all kinds of carp in the lake. And at that time, you never saw any weeds in your back bays. But now that there's very few carp in the lake, the grass is growing up everywhere. So I'm assuming that's a good thing, unless you got a motorboat and you're getting anchored in it.
Right. That's a good, so there's a few areas where it's a good question. It's interesting. So carp are brutal for turning up sediment into the water column and making the water essentially dirtier. And then by making the water dirtier, it's more difficult for sun to penetrate into the water, which would have an impact on the ability for plants and emergent kind of plants that come out from the bottom of the water and out of the water, say like wild rice, for example, to grow. And so it does make quite a bit of sense when there's not carp around, there's not as much to stir up the bottom sediments, not as much to block out sunlight. And so vegetation is starting to take over a little bit more. That would be the feedback I would expect. So there's places like, I'm not sure if anybody is from Hamilton. I went to McMaster from my undergrad, and there's a place back behind McMaster called Coots Paradise. You can kind of see it off 403s are coming into Hamilton, and they put in carp gates from Hamilton Harbor. So Hamilton Harbor is connected underneath the highway into Coots Paradise, and they put carp gates in there in order to exclude carp from Coots Paradise because it was impacting by that same mechanism the kind of ecology of this Coots Paradise, which is a shallow pond, like wetland lake kind of thing, like very shallow lake that is important habitat for multiple species. And so it was starting to really impact the ecology, and they extirpated removed the carp from the area. So essentially these gates where they can leave but not come in, and it really cleaned, like the whole Coots Paradise has really taken off ecologically since then. So makes me think of that a little bit.
Carl, I wonder if you could just make some very basic comments about tree removal. I know you've talked about vegetation, but I think trees in particular A lot of times, I read an article in Maclean's recently about people who buy lots and then take down all the trees in front of the cottage, or if they're not allowed to take down the trees, they cut the branches off almost all the way up except the very top. Anyway, I just wondered if you would make a few quick comments about the impact of tree removal specifically.
Yeah. So for me, taking a tree down, one tree down can often open up an entire view, or a few branches off of a tree can open up an entire view. And I think at some level, it could be okay. But every time you remove a single tree, you're removing bird habitat. In a major way, you're removing, so trees move a ton of water out of soil and into the atmosphere, like a ton. And so when you leave trees in, there is a feedback that helps to protect from all this runoff, for example, that can happen is one thing. So if you're removing a lot of water out of the soil and into the atmosphere, that transpires or evapotranspires into the atmosphere, then you don't have this soaking kind of shoreline the whole time. And when rain happens, there's more an ability therefore for the shoreline to act like a sponge and actually suck stuff up, including water and whatever's in it. Trees as well have, depending on the tree, have very extensive rooting systems, and it stabilizes soil. So they definitely help to stabilize against erosion and other impacts related to that. So, in first year environmental science, we teach a common thing, there's negative feedbacks and positive feedbacks that happen in the environment, and kind of negative feedbacks, the ones that they sound negative, but they're the ones that are helpful to the environment. So, something happens and something changes it so it stays stable and you don't kind of move in one direction. But, in a positive feedback, maybe you have a tree that goes down and then it starts to erode a little bit around where that tree was because the tree roots were kind of holding that soil stable. And then you erode as much, and then it gets to the erosion gets to the next tree, and another tree kind of falls in, and then it erodes some more, and then another tree falls in, and you get this kind of sequence that happens that continues. And so there's possibility that removing trees really removes a number of protections, but especially protections against erosion. The canopy of trees, huge storms can slow down exactly, vegetation in general can slow down exactly how impactful raindrops might be in these shoreline areas. There's kind of multiple small reasons that kind of accumulate into, a lot of services that happen by keeping the trees there.
And I think the temperature of the lake is affected by tree removal, is it not?
Potentially, it depends on the size of the lake. Streams and stuff like that are highly impacted by tree removal because of sunlight shading and versus penetration of sunlight by not having the canopy there. I don't have a very good feel for how big the impact would be in a large lake for the temperature, but it could, I suppose.
Okay. P. Thompson, if you could unmute yourself and go ahead and ask your question, please.
Great. Thank you very much. My name is Paul Thompson, and first of all, thank you very much for the invite for tonight. We're not part of your local community, but we're certainly interested in learning as much as we can about lake capacity, and have seen some of your billboards along the side of the 124. So clearly from the work that you've done, I hear the level of involvement, engagement that your committees have had over the years, and it's wonderful that I think we're all working for the shared purpose. We're out on Wawash Cache. But I guess my more direct question, and it may be beyond the scope of this meeting, and if it is, that's fine. But Carl, you mentioned one of the benefits of maintaining and really taking the information that you gather seriously and over time is it allows you to get in front of a problem. It allows you to sort of see those changes. And correct me if I'm wrong, I think part of what you're doing is is wound up in maybe a historical interim control bylaw, and maybe my sense is that the municipality may also be sympathetic to understanding what's going on with your lake. I guess my direct question is, what impact has your research, your finding, your work, what impact is it having on the lake carrying capacity from a development point of view? I think your presentation has been bang on as far as lake stewards and property owners and the good neighbor side of things. But in your experience, what impact has this kind of work had on informing or supporting or providing information for broader planning decisions?
It's a good question. I mean, I think it's in the scope of this, and I can answer the best of my ability. I can tell you that you start to move. I mean, I'm a scientist and never want to be a politician, so I'll throw in. But you start to move from the science into the politics a little bit, and to me, I would feel like if I was a politician, I'd want as much information as possible that would help me make a decision and then use that to make whatever decision happens to be. So there is an aspect of this that I wouldn't bet my house on it, but it helps to inform using, say, something like the lakeshore capacity model to think about how much more development could happen on the shoreline of a particular lake without necessarily having a detrimental impact or a serious detrimental impact on the water quality of that lake. So there is aspects of this that could be used to think about how much more capacity the lake has for development. I'm very wary to say, oh yeah, we could put in 2 more subdivisions and 300 more houses and everything would be fine. Or if you put 1 more house, nothing, that will be the tipping point. It is a little bit difficult to say, but I think there's like something that needs to happen in between there. So what I find with the committees in McKellar anyways, is to say the committees that we're on, so the research that we do or the things that happen on the lake, and it's not just me doing this stuff, there's the MLCA and the lake stewards, and there's multiple people that are involved with collecting information that exists. There are counselors from the township that are involved in each of the committees for these different things, and so at least in my mind, there is a direct line of communication between things that happen, such as this, and therefore, a communication line that goes into council and the politicians that actually make the decisions ultimately on these types of things. And so, I mean, whether or not that's taken seriously and exactly how it balances in terms of prioritization of which issues make for a particular decision, I feel people can advocate for that, and then the politicians kind of make the decisions. I think that I feel like the township's pretty serious about these kind of things, but I mean I suppose it's the final outcome of some of whether or not there's a ton more development or not tells you how seriously these things happen to be. I don't know, that's a really vague answer, I suppose, right? But I feel like it's communication, as long as there is some sort of level of communication between how these things are, how the knowledge is developed and towards the people that are actually making decisions. It's not like we're making decisions for them. We're just trying to provide information. And then hopefully the people that we've elected are making these proper decisions. My experience in Toronto is extremely different than McKellar, but and I feel that I'll tell you that if I felt that things that we did were not taken seriously whatsoever, I've got better things to do, if that makes sense. And so I feel like I wouldn't have spent some time doing this if I felt that it was for waste.
Well,
But I think it takes some effort. Yeah.
Your passion for your lake certainly comes. You have a beautiful lake. I've been able to visit it, and I think there's a real power in what you've been able to provide tonight, because you provided people with an opportunity to have questions to ask their counselors as far as what their support's going to be. You spoke about there's an intent in your official plan that may not be upheld in practice. Those are the kind of things that I think, I'm glad you mentioned Coots Paradise. Many of my, Christmas trees on I live in Burlington, many of the Christmas trees that are put out at the end of the driveway end up in those carp dams, and we've had a significant impact. So small things make a huge difference. So thank you very much for the invite, and thank you very much for the information you shared tonight.
My pleasure.
Are there any other comments or questions for Carl? Well, if not, I just want to give you my sincere
Hi there,
thanks.
I've got a question actually.
Oh, another question, good.
Yeah, Carl, do you have any suggestions about sort of educational strategies? You were talking about that we need education for homeowners about maintaining shorelines and things like that. Have you sort of seen projects like just this week? We received like a workbook, and I don't know if the MLCA was circulating that or but it was about sort of shoreline management, and so that's one idea. But I was just sort of wondering what you thought about other ideas to educate people. It seems to me, for example, it might be a good idea to educate realtors, because realtors are the people who are selling properties to people who may not have any idea about what they can or can't do or should or shouldn't do. With the waterfront, they see a property and go like, great, I'm going to, terraform this whole thing and put in a beach and all this stuff. And anyway, I just was curious what your thoughts were about that.
It's almost like a planted question. Good question. The I joke in a way, but so the committee that we're on, and then the township I think in partnership with the MLCA, kind of everyone's involved with having those workshop or those workbooks. And I mean, Jennifer in particular, for sure, I know, and Susan and others that are on the committee to get those workbooks out. So that was, one action that came out of starting to get some of these data along in the last year, to think about things that needed to be thought about, and then how do we, but that's the good question, like what are the mechanisms for education that might work the best? And I haven't heard the one about particularly thinking about educating realtors, but I think it's an excellent suggestion. It's not something that I thought about previously. I do think that that's a big bottleneck. I don't want to pick on people, but I think, especially new cottage owners and people that maybe have spent a mostly urban life. Like, I think as people move into cottages, I think they start to gather this information and start to understand, and they're probably here for a purpose. And many people come already knowing a lot of things, but I think that is a really important point, is to try and get these new people as they move in to think about this immediately, because I think the sooner they're thought about, the less time there is to have done actions that are detrimental before you start to understand kind of more about what's going on. It's a good question. I mean, as an educator, I have my goal, I can't just sit here and lecture at everybody for, every Tuesday or something like that about what's going on. It gets kind of, those things get old. So I think I know the committee would be super interested in hearing feedback from anyone about those kind of ideas, but I'm sure the next time we have the Lake Stewardship and Environment Committee meeting, that this realtor idea will come up. But I mean, what is being done is these committees, and so that these workbooks that were invested in to distribute to all of the citizens and the entirety of McKellar. Members of the MLCA man a tent at the McKellar market every week that have kind of multiple brochures and other posters and other parts of information on multiple aspects of living on the lake and the environment in general, and how to protect these things. The more cliche thing, but very effective thing is outreach efforts that happen with children in schools. I think a huge thing is tends to be, and I know this happens, like the Georgian Bay Biosphere Reserve and stuff goes into schools, and other people go into schools, but those outreach efforts can kind of really amplify, because children tend to come home to their parents and grandparents and are very blunt about, why are you cutting that tree down? And that's stupid. Like they'll actually tell you exactly what they think, kind of based on what they've learned. And so kids can be quite good at disseminating information amongst an adult cohort, and making them think about the actions of what they're doing a little bit more deeply. But yeah, that's no, I'm not sure exactly about there. I'm sure there's multiple ways. I'd love to hear what people have thought are effective ways that have changed their mind or made them, behave slightly differently.
I just want to give a little plug to a new program that the MLCA started to help individual cottage owners assess their property and give them advice. We have a lot of expertise in the community that the MLCA has mobilized to help people decide what to plant if they want to replace their grass and naturalize their property. So that's a great program too. Okay, does anybody else have any questions or comments? Good. Well, it's been a fascinating seminar and discussion, Carl, and we really appreciate having your expertise on the committee, and appreciate you sharing your expertise with the Lake community in McKellar Township. And it's really quite thrilling to have your knowledge and your skills available to us, and anything that we can do to help your research, we'll certainly do that as well. So
It's
many
my pleasure.
thanks.
Thank you very much.
Okay, thank you for attending, and we'll see you at the next meeting, hopefully, of the September the 8th is our next meeting of the Lake Stewardship and Environmental Committee, and it is a public meeting. And you will find the link on the township website. So take care, everybody. Enjoy the rest of your evening, and I'll end the meeting now.